The Future, Lexile 1270. Publication, Sports Illustrated, March 17th, 2008. Author, David Epstein. Think performance enhancers are a problem now? Welcome to the era of genetically engineered superathlete. I am one of the most avid sports fans you'll find. C. Jin Lee says, it's true. He'll watch anything basketball, football, billiards, on 700 channel, whatever. As a graduate student in the 80s, Lee used to sit in his car in the driveway with the radio on to listen to the games of faraway baseball teams. Even now, in his lab at Johns Hopkins Medical School in Baltimore, he easily rattles off the NCAA basketball tournament winners in order from 1964 to 2007. And, like anyone who values fair competition these days, he's disturbed by the issue of performance enhancing drugs in sports. Why then is Lee working to usher in technology that will make even today's most inventive doping methods look primitive? A professor of molecular biology and genetics, the 49-year-old Lee studies genes that tell muscles what to do, genes that he knows how to change. As clever as chemists are in altering steroid molecules to avoid detection, recall Balco's, aka the clear, those designer drugs can be spotted once anti-doping agencies know what to look for. Even human growth hormones will be detectable soon, after a valid blood test becomes commercially available. But if athletes develop ways to alter their genes, the very blueprints for their own muscles, there may be no test of blood or urine that can pick that up. Lee is publishing the frontier of genetic research into muscle building because the same breakthroughs that could boost performance in sports might also bring about a medical revolution. Advances could not only mitigate the effects of diseases like muscular dystrophy, but also give senior citizens back their strength, which often would amount to giving them back their lives. In 1995, his lab on North Wolf Street, Lee and two colleagues identified the function of myostatin, a protein that tells muscles when to stop growing. It does so, scientists believe, by signaling satellite cells or stem cells that lie dormant around the muscle until they're needed to build or repair it. Experimenting on mice, Lee inactivated both copies of the gene in an animal that code for myostatin. The result, over 4 to 6 weeks, the rodents developed twice their normal muscle mass without a formal exercise regimen. After Lee's results were published in 1997, he was awash in emails from people wanting muscle wasting disease. No surprise, offering themselves as subjects for human experiment. He got similar offers, surprise, from bodybuilders and athletes. Imagine, double the muscle mass. Could he do to them what he had done on the mice? Some of the athletes barely knew what they were inquiring about. They didn't ask Lee where they could purchase some myostatin. Of course, they didn't want myostatin, he says. They wanted to block it. But if they could block it with a synthetic gene, the alteration would be part of their DNA, and it would last for years at the center of their cells. The most straightforward way of detecting the new gene would be to remove a piece of muscle and probe for it, a procedure most likely too invasive for wide-scale use. It would be enough to make one long for the simplicity of the steroid era. The year after Lee's mice results went public, H. Lee Sweeney, a physiology professor at the University of Pennsylvania, published a paper detailing his own mighty mice, which he had injected with a gene engineered to produce a muscle builder called insulin-like growth factor IGF-1. Sweeney, too, was inundated with inquiries from athletes. He says a high school football coach and a high school wrestling coach volunteered their entire teams as guinea pigs. Since the gene escaped from the bottle a decade ago, researchers have discovered dozens more genes that appear to affect athletic performance. This is old news in the rodent community. Scientists have created mice whose bodies are flooded with oxygen-carrying red blood cells, creating greater endurance. Other mice have been engineered to produce extraordinary amounts of growth hormone, while still others metabolize fat and carbs in such a way they can live like couch potatoes yet run like marathoners. Significantly, safety hurdles remain before the gene therapy is widespread for humans. The most efficient means of delivering a synthetic gene is by attaching it to a virus that shuttles it into human cells. Viruses are great at that. They can also trigger the immune system in a way that can lead to fatal results. In 1999, Jesse Gelsinger, an 18-year-old with a rare liver disease who had volunteered for a gene therapy trial, died from a massive immune response to a virus used in the treatment. And the dangers extend beyond the immune system. In gene therapy trial in France, 12 boys were successfully treated for X-linked severe combined immunodeficiency, commonly known as bubble boy syndrome. But at last 3 of them developed leukemia. One delivery method, flushing the bloodstream with the desired gene, is simple enough, says Sweeney, that it could be achieved by a clever undergrad in a molecular biology lab. The method is not very efficient and hasn't been thoroughly tested, but it hints at the possibilities for the spread of gene tampering in sports. Despite the unknowns and the dangers, chances are good that someone at the Beijing Olympics in August, someone willing to weigh his or her morality in gold, will have undergone gene transfer in an attempt to enhance performance. Even when I tell them it's not safe, Sweeney says, some athletes are willing to try anything. The signs are ominous. In January 2006, during German track coach Thomas Springstein's trial on charges of providing performance-enhancing drugs to minors, evidence emerged indicating that Springsteen had attempted to procure Ropoxygen, a gene therapy drug developed to treat anemia by promoting cells to produce EPO, and in turn red blood cells. He was found guilty of giving illegal substances to minors and received a 16-month suspended sentence. In addition, Mario Di Pasquale, the 1976 world powerlifting champion and an Ontario physician who has written several books on sports doping, says he knows that athletes are experimenting with gene doping with the help of Chinese doctors and researchers. Human data relating to myostatin has been hard to come by. Soon after its discovery, Lee attempted to identify potential test subjects with natural mutations in their myostatin genes. He placed an ad in Muscle and Fitness, and close to 1,000 muscle-bound men and women responded. But after collecting samples from 150 of them, he has yet to find a single gene with the myostatin mutation he had engineered in his mice. From his study of Belgian blue cattle, Lee knew that the mutation could occur naturally. A cross between the Shorthorn and the Holstein, which have been bred for some 150 years, these massive animals look as if their skin has been stuffed with watermelons. Lee got in touch with D. Garrels, owner of the Lakeview Belgian Blue Ranch in Stockton, Missouri, who sent him samples for testing. Garrels knew Belgian Blues were strong. Her 2,500-pound bull once ripped a metal restraining gate off its hinges with its horns to get a cow in heat, and Lee found out why. He discovered that they had mutations in their myostatin genes. Lee didn't see the power of a human myostatin mutation until Marcus Schuck contacted him in 2003. A pediatric neurologist in Berlin, Schuck had been summoned 3 years earlier to examine a jittery baby in the nursery at Charité Hospital in Berlin, where he was taken aback by the newborn's chiseled calves and sculpted quads. By the age of 4, the boy could hold up a pair of 6.6-pound dumbbells at arm's length. Schuck had been monitoring the boy's development, and he had got in touch with him, who confirmed the boy had mutations on both myostatin-coding genes, leaving no detectable amount of the protein in his body. Apparently, it ran in the family. The boy's mother, who was 24 when she gave birth to the super baby, had a mutation on one of her 2 myostatin genes, presumably leaving her less of the protein than normal, but not so little that she was as muscle-bound as her son. Nevertheless, she is a testament to the tantalizing temptation of gene doping. Super Baby's mother, the only adult in the world with a documented myostatin mutation, was a professional sprinter. The World Anti-Doping Agency has banned gene tampering in athletes and spent millions attempting to develop tests to identify it. Such a procedure will require technology unlike any employed by anti-doping scientists. The theory, according to Ted Friedman, the scientist leading WADA's search for gene doping countermeasures, is to fight genes with genes. If one medical breakthrough is revolutionizing doping, perhaps another can beat it back. Thanks to the Human Genome Project, someday all of us could carry our entire genetic blueprint on a microchip, which we'd present to doctors during medical treatment. As the technology matures, Friedman hopes athletes' genomes can be screened and that the gene doping markers or signatures will emerge. As pharmaceutical companies race to turn genetic research into medicine, new gene therapy drugs could come to market in mass over the coming years. In practical terms, it will be impossible to develop specific tests for each of them. We can keep buying instruments and keep building labs, says pharmacologist Dan Catlin, founder of the UCLA Olympic Laboratory, but the anti-doping industry isn't like Exxon. There are certain limits. Perhaps a time will come when there is no longer a need to define those limits, not because of new artillery in the war on doping, but because gene therapy will have become so widespread that it will be as controversial as Flintstone chewables. So far, Sweeney has aided anti-doping officials, but I've often told WADA my position would change if gene therapy is proven to be safe, he says. Then we're withholding something that would make the athletes healthier. That would in turn raise a new series of questions. What is it we seek to gain from sport? Do we want to see larger-than-life behemoths swatting 600-foot home runs, or do we prefer to see people more like us pressing the limits of their strength and skill? After all, with their legions of doctors and coaches and cutting-edge equipment, professional athletes, doped or not, are hardly us. The gravest danger in the debate over gene transfer is not that athletes might taint sport by tampering with their genes. It's by abusing such treatment, they'll create the same stigma for gene therapy that they have for steroids. Pat Furlong has felt the effects of that stigma. She is the head of Parent Project Muscular Dystrophy. Her two sons began life happy and healthy, and then over 10 to 15 years, you watch them go away. Helpless, she says, part of her job is to persuade parents of kids with muscular dystrophy and their doctors that anabolic steroids are beneficial. I get calls from parents nervous about steroids because of what they've heard, she says, but the flip side is that steroids have benefits in people who are losing function. In Duchenne muscular dystrophy, it's all we have. We know there's no drug that will come without side effects, but steroids are an option to preserve and protect muscle for a few minutes longer, or a few months longer, or a few more years. The local newscast and Congress rarely mention the part about how they can help kids with MD walk longer, which keeps their spine straight and helps them breathe better. As he stands at the edge looking over the gene doping precipice, Gene Lee has similar concerns. The hysteria that will ensue when an athlete is caught gene doping, Lee frets, will result in restrictions on gene therapy drugs, making them hard to obtain by those who truly need them. If an athlete did cheat, it was his choice, Lee says. If the league turned its back and allowed that to happen, it was their choice. Patients with debilitating diseases did not get there by choice. Sports in real time, all the time, all free. More on the future. Stem cells might one day not only lengthen an athlete's career, but also speed recovery from his or her injuries. SportsIllustrated.com/steroids. By David Epstein.